The MIT Energy Initiative presents New Class Explores Paths to Reducing Transportation Emissions, written by Catherine M. O'Neill. Transportation is responsible for nearly a quarter of all energy-related carbon dioxide (CO2) emissions worldwide, making decarbonizing the sector critical to reducing carbon emissions and addressing climate change. Last fall, MIT unveiled a new course, 11.149/11.449, Decarbonizing Urban Mobility, to introduce students to the factors involved in addressing this complex challenge. We want people to be grounded in reality so they can make good decisions about what it takes to get to zero carbon emissions, says Andrew Salzberg, a lecturer in MIT's Department of Urban Studies and Planning. The former head of transportation policy at Uber, Salzberg taught the class together with Jinhua Zhao, the Edward and Joyce Lind Associate Professor of City and Transportation Planning and Director of the MIT Mobility Initiative. This course, the first of its kind at MIT, works to place transportation in the context of broader decarbonization efforts while also situating the decarbonization challenge in the specific landscape of transportation planning, Zhao says. Transportation is now the leading source of carbon pollution in the United States. This is a unique moment that calls for a course specifically and narrowly focused on decarbonization in urban mobility. Urban mobility is an important focus because cities are at the epicenter of the technology revolution taking place in mobility, with new options such as ride-sharing, autonomous vehicles, and passenger drones. Nevertheless, transportation has proved stubbornly difficult to decarbonize, making the sector ripe for further studies, Zhao says. Transportation presents a special challenge because it involves just about everyone, Salzberg says. We're talking about hundreds of millions of vehicles, almost all burning fossil fuels. So there are a great many decision makers who are choosing how they want to get around, he says. You have to win a lot of hearts and minds, so that makes it hard. The complexity of the topic came as a surprise to Pravaja Balaji, 24, a computer science and engineering major who took the inaugural class in fall 2021. I thought if everyone just adopted electric vehicles and took public transportation, we'd be good, she says. Instead, Balaji learned that many factors contribute to the problem, including how far people need to travel, the fuel efficiency of vehicles, and the amount of carbon emitted to power vehicles, even electric cars, which can draw power from either renewable or fossil fuel sources. There are also myriad possible solutions, including not only the adoption of more energy-efficient modes of transportation, but also policy approaches such as establishing low-emission zones or imposing carbon taxes. When you talk about decarbonizing transportation, two main themes are to approach it with technology, electric cars, clean energy, etc., or through the policy side. We tried to emphasize to students that just one or the other was not going to be a sufficient approach, given the scale of the problem, says Nicholas Karos, a PhD student in civil and environmental engineering, who served as a teaching assistant for the class. Hopefully this expanded their thinking. Decarbonizing transportation is a hot topic, so there's a lot of information out there, but it's hard to understand what you should prioritize, says Narawa Karetti Sanchez, a PhD student in the Media Lab who took the class, which was open to both undergraduate and graduate students. They don't give you the answers, of course, but it's a very good class in the sense that you start to understand that these are the tools that we have, these are the potential impacts, and these are the challenges. Quantitative approach. To help students assess decarbonizing options, the faculty began by introducing a mathematical construct known as the Kaya identity, which uses factors such as population, gross domestic product, and energy consumption data to quantify how much human sources contribute to carbon emissions. It's MIT, so it helps to be quantitative when we can, Salzberg says. Karos explains that transportation emissions are also broken down into contributing factors, with each providing a lever for control. The components of a commute by car, for example, would include how energy efficient the vehicle is, but also the distance traveled. So while technology can make the vehicle more energy efficient, working from home could reduce emissions even further, which was a key takeaway for Karetti. One of the biggest lessons from the class is the importance of reducing the vehicle miles traveled, she says. Similarly, while public transportation can often be a better choice in terms of emissions, that's not invariably the case. If you're the only person on the bus, taking it might be a worse decision than driving by yourself, Karos says. To illustrate such trade-offs, in one assignment, the instructors gave students a simple spreadsheet tool and asked them to design their own pathways to reducing Boston's carbon emissions. It was a sobering exercise, Salzberg says, because even in a city like Boston with fairly robust public transportation options, it's hard to find alternatives to driving for long distances. Students were also assigned to debate decarbonization solutions. They could choose either to reduce vehicle miles traveled or to electrify everything. But after choosing their topics, Salzberg had the students argue the opposing point of view. That was a very good experience, Coretti says. I was going to argue for reducing vehicle miles traveled. Then I switched to electrification and learned that there are also very valid arguments for that option. Learning from experts. Over the course of the semester, students heard from more than a dozen guest speakers on topics ranging from city planning to the power generation needs of electric vehicles. We've never decarbonized transportation, so you can't look back to get those lessons. We're trying to learn from people who are doing it as we speak, Salzberg says. Reed Ewing, a professor of city and metropolitan planning at the University of Utah, explained that city design directly impacts transportation emissions since people in dense cities, such as New York or Boston, don't have to travel as far for everyday activities as do residents of sprawling cities such as Houston. Nathaniel Hordam, a managing consultant at the nonprofit Center for Transportation and the Environment, illuminated the challenges of switching to battery-powered electric buses. They don't work very well in the cold, the batteries don't perform as well, and you have to heat the bus, Karos says. Balaji says she most enjoyed the talk by Greg Rogers from Nuro, a robotics company that makes autonomous, zero-emission delivery vehicles. It was interesting to hear his perspective on how that kind of transportation will impact climate change, she says. A variety of solutions. For the final assignment, Salzberg and Zhao asked students to lay out a strategy for reducing emissions in a city of their choice. Proposed solutions varied from electrifying New York City's taxi fleet to revamping the parking requirements for new buildings in San Diego. Balaji, for example, focused on the advantages of electrifying Boston's bus fleet. Coretti, who is working on autonomous bicycles for her PhD research, examined the impact on emissions of enabling shared bicycles to relocate themselves to spots where they are most needed. Currently, trucks are often used for this job. We gave them no constraints, Salzberg says. The range of projects, from parking standards to bike lane design, felt like a real endorsement of the whole idea of the course, which is that there's a wide range of solutions that we should be talking about together. For Coretti, the assignment underscored her main takeaway from the class. You have to do a lot of everything to meet the climate target. Salzberg and Zhao note that 11.149/11.449 Decarbonizing Urban Mobility will be held again in fall of 2022. Down the line, the class will also be publicly available to online audiences via MITx, thanks to a project supported by the MIT Energy Initiative and underwritten in part by a grant from the UN Habitat Program.